Hi everyone, welcome back to the channel. In today's video, we are diving deep into something that's at the heart of cloud security, IAM or Identity and Access Management in AWS. If you have ever worked with AWS, you know how crucial IAM roles, users, and policies are for controlling access to your resources. But don't worry, we are going to break it down into simple actionable steps using AWS CDK. We will be covering the core components, IAM users, roles, groups, and policies. Then we will get hands-on and show you the ideal ways to manage permissions using AWS CDK, creating policies, attaching them, and how to use assume roles for cross-account access. By the end of this video, you will not only understand how these pieces work, but also how to efficiently and securely assign permissions in your CDK applications. Let's get started. Creating users or building them during the CI/CD process or during infrastructure code could be not very common, but there are some cases you need to create users in your infrastructure code just as a self-service approach or as a trigger for something in your process. But let's cover how we create users and give them enough permissions as part of the infrastructure as code, as well as creating other services that we assign roles for them and policies so that we see IAM roles in action working with CDK code. In our first code, we will write a code that creates users. We will initially create users in CDK and giving them enough permission so that when you authenticate, you can access an S3 bucket and upload a file to them. And later, instead of the user directly access the S3 bucket, we will create a Lambda function that will assume role, and with the enough permission, it could access S3 buckets and change the files, upload them or read them. And with enough permissions for users, it could access the Lambda functions and invoke them. Later, we will learn how will we assume role from users, and with enough permissions again that will be returned by assuming the role, the user can invoke the Lambda and do what they could do when they were directly accessing the S3 bucket. Let's go ahead and see how would we achieve this with code. Starting by an empty CDK project, let's import the IAM library first and create our test user. Let's name it test user and deploy. After deployment is complete, let's go to the management console and try to log in with the new user. Make sure you enter your account number here and username is test user. Let's copy this password and sign in. After the user signs in, you see that we don't have access to anything, like only the login profile, which allows us to log into AWS management console, but nothing else is allowed. If we open S3, for example, it will direct you to the default documentation page. We cannot see the buckets. We don't have permission to even list the buckets. Let's go back to code and try to add some permissions to our user and see their effect on how would we react or how would we interact with the management console. The first permission we are going to add it directly to the user is the managed permission for read-only S3 access. The way we add policies is by accessing the add managed policy function of the user. So let's deploy and see the effect of this policy on our user. When it asks you for confirmation, enter Y and enter. Checking the user after we added S3 read-only permissions, if we refresh this page, it should allow us to see the bucket list. As you can see, now we can see bucket list here. We can read buckets, but we don't have permission to write or change any of these buckets. Let's go back to code and create a bucket and see how would we interact with this bucket if we don't have permission and after we create enough permission to upload files to this bucket. Let's remove this managed policy and revert our user back to user without any permission and create this bucket. We need to import the S3 library created demo bucket with this name and no permission at all for our user. To assign permission for the user to access the bucket, we can use the grant method. It is the direct and most straightforward way in CDK to give permissions to principals, either users, services, or applications to access the resource. In our example here, our demo bucket can grant, delete, public access, put ACL, read write. Let's pick read write, and the input to this function is the user that we are creating here. So now we created an S3 bucket and gave our user read write access to this bucket. Let's deploy and see this in action. CDK asks us for confirmation. We enter Y and continue deployment. It gives me this error because this bucket name was already used previously. Let's change it by adding any suffix like a random number and try again. Make sure that the bucket name is unique because S3 buckets are unique. They should be unique across all S3 buckets created in AWS, even not your buckets. Let's try again and deploy with this bucket name. Now let's refresh this page and see the effect of changing the permission of our users for read write only for one bucket. We cannot list the buckets. So it's very tricky. You have to be able to list the buckets so that you can see the list of buckets when you try to access one of them. This user now have access to list to check this bucket and write and read from it, but the user does not have access to list the bucket so that we can pick one of them. So let's add the read-only access back to the user so we can see the list of buckets. After we added the list, the S3 read-only access again to our user. So let's refresh, and now we are able to see the list of buckets. Where is our bucket that we have read-write access to it? It is this one. So let's open it, upload a file, any sample file. You must add files, test file, open, upload. And it also accepted the upload function. So our user is able to read, write to this bucket and able to list all the buckets in the account. Back to our code, and let's add the Lambda function that can access this bucket and use the grant functions to assign this Lambda read write access to some buckets and see it in action. Before creating the Lambda function infrastructure, let's create the Lambda function handler code. Feel free to copy this code. I'm going to add the GitHub for this code in the comments. The handler is dependent on the configuration of the bucket, source bucket, destination bucket. This handler actually copies a file from a source bucket to the destination bucket based on user trigger event. If we go back to our architecture here, our user should be able to access and invoke the Lambda function, and this Lambda function should be able to assume a role and read write to a bucket. Back to the code. We don't actually need to understand everything here, but it's a basic JavaScript code that get an object from bucket and send it to another bucket. It should have read access to the source bucket and read write access to the destination. Here is our JavaScript code. Let's create the infrastructure for it. First, create the source and destination buckets. We can create buckets without giving them names. That's possible, and AWS will create random names for them. So let's do that. We don't need to create a name for these buckets, and we could figure out the buckets themselves in the console by the source bucket and destination bucket. This will be part of the name anyway. Let's create the Lambda function itself. Import the Lambda library first, of course. This code should take care of the Node.js version, which latest version, the function name, the assets, which is the handler file that we created in a folder called Lambda, and the handler name. It should be matching the handler name and the file name, and the environment variables. because the code makes use of these variables, source bucket and destination bucket. What's missing here? Exactly. The missing part here is the permissions. So this function does not have permission to read or write to any of these buckets. To do that, we are going to use the smart read, the smart grant read, grant write permission functions. With source bucket, grant read to our function, and destination bucket should grant write to our function. And the code better. And let's go to the management console and see what we have just uploaded by the CDK deploy. Going back to Lambda, notice that we are logged in by the demo user that we created in our code. And this user does not have access actually to view even the Lambda functions. So we either log in with a better user, the user with more permissions, or give the enough permissions to this user to view the Lambda so that the user we can see the permission of the Lambda on the console, and we can trigger or invoke this Lambda by this user. Let's go back to the code and add the enough permissions needed for this user. To enable our user to access the Lambda functions or to list our Lambda functions in the AWS account, we use the similar approach as we used for the S3, and there is a managed policy for that purpose. Let's add it, and this managed policy is called AWS Lambda _ read only access. Let's save and deploy. Let's look at the management console after we added the enough permission for our user to access Lambda. Refresh, and you see we can see the list of Lambda functions, which for now it's only one. For this Lambda function, I would like to show you some very interesting features. The most important one now is the role that's assigned to this Lambda. Going to configuration, permission, here is the role name. Let's look at this role and get some insights from what we see. The role has an attached policy, and this policy is a list of actions that we can achieve over the resources we have, the S3 bucket and its internal objects. It also has a higher permissions on this object somehow, boot, delete, abort. All these permissions were created for us when we used the grant read and grant write permissions over the buckets. And here is the buckets we created. So this for read and these are for write. Going back to the role and see the trust relationship. This is very important to understand. Permissions are not assigned straight away to our Lambda functions. Permissions are defined in a policy, and this policy is attached to our role, the role that was created for us by CDK, and Lambda functions, every time it accesses these S3 buckets, it needs to assume a role. That's why in this policy, we allow assume role to Lambda in our role. Let's see how our user could access this Lambda functions and invoke it in action and see the process of copying the file from source to destination. Back to the Lambda function, go to test. That's how we invoke a function, and we don't have to invoke Lambda function permission for our user. Going back to the code, what we attach it to our user here is a managed policy for read only. To be able to invoke the Lambda function, we need an invoke permission. And because our user, we need to go and upload a file to the source bucket so that we can trigger this one to copy this file. We need also to grant read-write permission for our users to the source bucket. Let's first do that before we forget. Source bucket to grant read-write to our user, and then grant the invoke. Let's see how would we do that with CDK. Grant invoke, exactly, and we grant it to our, and that's it. Let's deploy again and see that in action. Let's refresh. It's obvious now that our user can invoke the Lambda function, but let's first upload a file to our S3 bucket, the source bucket. I would like to upload the same file here. Where is our source bucket? That's very confusing because we have two buckets here with source bucket name in it. I would go back to the code and add some changes to our names so that we can identify the buckets. You know what? Let's define the source bucket name at least, or both of them. Bucket name, source bucket, IAM CDK demo, and some random numbers. Use exactly same object here, but use destination. And let's deploy that change. Let's check the S3 buckets after we change their names. So yeah, here is our source bucket and here is our destination bucket. Let's open our source bucket, upload a file, open it and upload. We were able to upload the file. That's because our user had enough permission to access this bucket and upload to it. Back to our Lambda function, open the Lambda function and let's test it with the file name that our function will copy. What's its name? It's test file.txt. Back to the code to show you why I'm entering it as a key. So the Lambda function accepts in the event a parameter called key, and it's going to use it as the key for the object that it's going to copy from the source to the destination. Back to here, let's test. It executed successfully and it's showing that it copied the file. Let's go back to S3 and check the destination bucket and the file is copied here. Back to the code and see what we have achieved. We were able to create a Lambda functions with enough permission to read from the source bucket and write to the source bucket, and we were able to attach managed policies to our user. We were able to grant, write, and invoke permissions, all using the grant functions of Lambda and the managed policy. The next step is to create a role and policies in CDK and either attach them to the Lambda functions to allow it to assume this role. And finally, we will allow our user to assume the role, and I will show you how users will assume roles from the management console. Now let's create the role in CDK and assume it by our Lambda function. We need to create a role that's assumable by Lambda function by mentioning the assume by is service principal with the lambda.amazon aws.com. That's to trust the relationship between Lambda and this role. We need to add more policy to that role. It's a managed policy for the Lambda execution. That's to make sure when we assign this role to our Lambda function, it has enough permissions to execute. Add the Lambda role here, and now this Lambda function is assigned to a role that we created ourselves. Let's comment the grant permission because we are going to create this assignment ourselves. As you are replacing the grant functions with directly interacting with the roles, we need to see what's going to happen or what CDK does for us with grant functions. You can see here for S3 access, for example, it creates two policies in the role it was created for us. One for read access for the source bucket and one for write access for destination bucket. Since the beginning of this video, we have been using managed policies. We didn't create any inline or customized policy. You can see here, for example, we used S3 read-only access to give our user access to all S3 buckets so that we can list them and we can read any of them, download files, give our user read-only access to Lambda, and this is a managed policy as well. But we cannot achieve this granular access using managed policies. Managed policies will give us access to system-wide functionalities. So the only way to achieve this granular level of accessibility or permission to services, we need to create inline policies. To achieve that, let's attach these inline policies to our role and see them in action. The first bit is the read only. Let's copy these permissions to our code and define the policy here. Const read only policy source IAM dot policy statement. We need to define both actions and resources for our policy. Actions, we already copied them from our created policy, and resources are the bucket and the objects in the bucket. Source bucket, bucket ARN. To define or to mention the objects, we use the string concatenation function of TypeScript and add this bucket name, the ARN again, /wildcard. Its format, why it's upset here? Yeah, it's upset because of this additional comma. Let's remove it and format. This policy should be enough to give read access to the bucket. Now let's go back to our AWS environment and copy these actions. This is for the destination bucket. Read, write, policy equal new IAM dot policy statement actions. The list of actions we copied from AWS environment. Resources are the destination bucket and its children. Copy this exact logic. And instead of source bucket, we mention destination bucket. We attach both policies to our Lambda role. Lambda role dot add to policy and read write policy. Again, Lambda role dot add to policy read only. This way we have achieved what CDK did for us by the grant function, but using the managed and inline policies together. It's obvious that the grant functions are better because it does everything for us. We don't need to do all of these changes to make it happen. But I'm demonstrating here is the ability to make or to create a very granular permissions ourselves using the policies and roles. Let's deploy that and see it in action. Let's go back to our management console after the deployment is done and check our Lambda function. Role was deleted. Search for Lambda. Configuration, permission, role. CDK deleted the old role and created a brand new role for us. It's named like we named it in our code. You see the enough permissions we need for read-only access for the source bucket and full read-write permissions for the destination bucket. Let's go back to our code and see how to use assume role, but now with user. We are going to achieve the grant read-write and grant invoke permissions that was created for us by CDK, but we are going to achieve them directly into the role and make our user assume this role to access the S3 bucket and the Lambda function. Const user role equal new IAM dot this default user role. Properties, we need at least the role name, CDK demo user role, and assume by is our user. Let's define two policy statements for the user. One to access the source and destination buckets, or the source bucket only. We don't need actually to access the destination bucket. We need to access it to check. So let's do that by creating a new policy. A new policy statement actions. Let's copy both read and write actions so that we make sure we can do everything with this policy. For resources, let's copy both source and destination buckets from the existing policies. User role dot policy and the new S3 access policy. Let's do a similar policy for invoking AWS Lambda function. Const policy equal new IAM policy statement. Again, resources, actions first, Lambda invoke function, resources, our Lambda function, and we need also to make sure it can access all the children functions below this function. To achieve that, we need to use function ARN colon asterisk user role of Lambda. Let's deploy that and see if it's different from what was done by CDK using the grant functions or not. As you can see from the outcomes or the output in terminal, CDK told us that it's going to create an assume role for the user with the new role, which is different from attaching the permissions directly to the user. Let's continue the deployment and see it on the AWS console and see how we'll make use of this assume role in the console. Let's go back to the management console and check what happened with our user. As you can see, we're still able to locate the Lambda functions and invoke them. So back to code, I believe we need to comment the grant functions so that user are only accessing the Lambda function through this role. So user has to assume the role before or to be able to access the Lambda function. So let's deploy this change again, CDK deploy. Let's go back to our management console and check after we removed the grant functions or commented out the call to grant functions on the S3 to our user. The Lambda and the S3 to our user. So check functions, refresh. As you can see, we are not able to perform the invoke function on the Lambda because the permissions are not directly attached to the user anymore, but they are part of the role. The policy created is part of the role, and the user need to assume this role to be able to invoke the function. I need to say that assume role for user is also very useful when we make cross-account access. So you can assume role from other account when the permission is enabled for you. Let's first see how we assume role in the same account. You see this when you click on the top right corner of the management console and see the drop-down list, switch role, click on switch role. As you can see, you can enter account ID because you might assume role from different account, not from your account. You mention the role name that you are going to assume and you give it a name that in the future you can use this assume role directly from your drop-down list. Let's get the account number, the role name defined here, and leave the name with the default. Give it a color. Now you are accessing this AWS account, the same user, but assuming a different role. Let's try to invoke the method. As you can see, it was able to invoke it. This error is not related to your access permissions. So let's go back to the code and see what we have achieved in this video. We were able to create a user using CDK and give it some managed policies that are attached directly to the user. We were able to create a bucket and a Lambda function and give the user the read permission or read-write permission to the bucket, the invoke permission to the Lambda, and again, using policies that attach to the user using the grant method, we were able to give the Lambda function an access to read or write to the S3 buckets using the grant methods, which create the role in the background for you, and the Lambda functions were able to assume the role, and we were able again to create the role ourselves and create the inline policies ourselves in this role and allow the Lambda function to assume this role. And at the end, we were able to demo how you can assume a role from an IAM user in the management console. One point I need to cover before I end this demo is the user group. So you can, instead of creating a user, if you want to use the same permissions for multiple users, you don't need every time to attach these policies to the new user. Instead, let's create a group, give it a name, demo group, and group user, our user. Specify a group name, CDK demo. Now, as promised, let's talk best practices when it comes to IAM permissions. First, always follow the principles of least privilege. You want to ensure that every user, role, or service has just enough access to get the job done. No more, no less. When working with AWS CDK, use managed policies whenever possible. AWS has tons of them already built for you. For more granular control, inline policies can be useful, but make sure they are necessary. And for cross-account setups, assume roles are the way to go, but be mindful of keeping trust policies as tight as possible. But don't forget to use tools like CDK NAG, which we have talked about in a previous video, to automatically check for security best practices in your CDK stacks. It's a lifesaver for catching potential security issues early. Alright, so let's recap what we covered today. We took a look at IAM and its key components, users, roles, groups, and policies. We then explored the best ways to create and assign permissions in AWS CDK, whether through managed or inline policies, using the current functions, and setting up cross-account assume role. Of course, we touched on some IAM best practices like the principles of least privilege and leveraging CDK NAG for security checks. If you found this video helpful, don't forget to give it a thumb up and subscribe for more awesome AWS content. Drop a comment below if you have any questions. And as always, thank you for watching. See you in the